All right, let's talk about the introduction to proportions. And let's talk about proportions for a second, shall we? All a proportion is, it's a fancy word for fancy term, for when one fraction is set equal to another fraction. But when we have something set equal to something else and they're fractions, they're called equivalent fractions. So when you deal with proportions, you're dealing with fractions that are equal. All right, that's the key part. All right, fractions that are equal, two of them set up, form a proportion, right? So what a proportion is, just like we said, are equivalent fractions, right? We're going to use these like crazy with all types of proportional relationships. You can set up a fraction or equivalent fractions in this case. And in equivalent fractions, the key part is both the numerator and the denominator are multiplied or divided by the same factor. And we're going to look at that first today. All right, the basic thing here is when we see these two equivalent fractions, 3/8 is equivalent to 15/40. Well, let's talk about that because they have a common factor between them. So let's see these for a second. As we can look at the numerators, the 3 and the 15, well, if I multiply 3 by 5, that's how I get 15. And remember, if they're equivalent, the same has to be true for the denominator. I have to do 8 times 5, and that gets me the 40, right? If those numbers were not the same, if I wasn't multiplying the top and the bottom by the same factor, they are not equivalent. So what makes them equivalent is this common factor between them. All right? Right? So if I decide to go backwards, again, I'm dividing by 5. 15 divided by 5 gives me 3. And 40 divided by 5 gives me 8. Right? I multiply in one direction, I divide in the other. Right? Getting bigger, I'm multiplying. Getting smaller, I'm dividing. But again, that 5 is the same top and bottom as a factor. All right, let's take a look, right? So when you see something like this, that just means multiplying to the right, dividing to the left, right? That's all it is right there, multiplying, dividing by a common factor of 5 to get these equivalent fractions. So for example, how does this work when you see a problem? Well, you just got to analyze. Look, I see on the top I have a 3 and I have a 12. What's a factor there? What is 3 multiplied by to get 12? Well, that is a times 4. Since they're equivalent, I must do the same to the denominator to find y. Right? So since 3 times 4 is 12, I do 5 times 4 in the denominator, and I get 20. So y is 20. That is it. If they're equivalent, find the common factor and use it. Let's take a look at another example. All right? Now I see the variable's in a different place. It doesn't matter. I have equivalent fractions. I'm still looking for w. But look at the denominator now. I have two numbers that I can find out a factor. I can see 2, and I see 14. Looks like I have times 7. Remember, since they're equivalent, I must multiply the top and the bottom by the same factor. So since 2 times 7 is 14, I'm going to do 3 times that same 7, and that's my 21. So w is 21. Right, and this works no matter what. Right, let's say I have this one, right? One more of these. Look, I got 20 and 100 in the denominator. I'm looking for z. Well, again, what's going on? 20 times what is 100? I could divide 100 divided by 20 to find that factor. 100 divided by 20, well, that one's 5. Just like that first example, we started 20 times 5 is 100. So I do, since that is 120 times 5, I do 17 times 5. And that's 85, and that's my answer for z. Right, so that's the basics of equivalent fractions. How can you find any one part of that? And that's how you would do it right there. Find your common factor and use it. All right, let's go practice.